Hmm. Bene, quindi credo che possiamo andare?
I think we can start.
Buon
Fine.
pomeriggio a tutti.
Good evening, everybody,
Grazie di essere
and
qui.
thank you for being here. I know that
Molto numerosi e questo
there
per
are
noi
many
è
of
un
us
ottimo
tuned in,
inizio per
and that's a great
la seconda
beginning
edizione della
to
Slow
start
Wine
the
Fair,
second edition of the Slow Wine Fair, which you all know very well
dal
will
26 al
be from the 26th to the 28th of February in Bologna. So
20 giorni.
it's going to happen in about 20 days' time. So it's great to have you here for such an important theme, the first of the three webinars that are going to introduce us to the event. We are on YouTube in direct streaming. And after hearing from these important speakers, whom I'd like to thank for being here this evening, after hearing from them, we'll be able to ask questions if you put the question in the chat. The three issues of the webinars are very topical, and we're going to start with the climate crisis, then denominations, and then organic farming and biological practices. So today, and then on the 15th, and then on the 22nd, Wednesdays. Now, we are going to have an agronomist and a trainer, Adriano Zago, and he's going to introduce our speakers, and he's going to take us right to the main issue of the climate crisis and its relationship with wine growing. So I'd like to give the floor to Adriano for him to introduce the meeting and present the speakers. Adriano, the floor to you. Thank you, Federico. Good evening, everybody, and thanks for attending in such large numbers. I'd like to thank my colleagues and speakers who have accepted to be here. Now let me present the people and say why we've developed this meeting in this particular way. The question of the climate change seen from three different points of view: the soil, the plant, and man. That's why we have Franco Meggio, who is an associate professor at the University of Padua. We're going to start with him to see how the plant is doing faced with this climate change. And then we're going to have Martina. She has great experience as an agronomist, and she is a studier of the student of the soil, and she's going to give us an idea about that. And then we're going to hear from the great experience of Alberto, who's going to talk about a specific theme within what is fertility in the soil. In other words, what happens at the level of the microbiological level and the microbiome. And I'm going to give you some experience from my point of view as an entrepreneur, talking about what is happening to the farmer. How can man, the entrepreneur, the farmer, the man who works on the land, how is he developing solutions to try and face the climate change and the dramatic changes that are ongoing? So we're going to try and use our time as well as possible. So Franco, I'd like to give you the floor right off to start. Thank you once again for being here. Okay, thank you. If you'd like to give me feedback.
Maddalena e tutto il team Slow Food che ci ha ospitato e ci ha coordinato, sempre da remoto purtroppo, ma spero ci sarà l'occasione per farlo anche di persona presto. Allora, due parole per introdurmi. Io sono un docente dell'Università di Padova, mi occupo da una ventina d'anni di relazioni fra pianta e ambiente, e quanto mai, visto che la vite è una pianta perenne che deve stare nel vigneto, non può andarsene quando ha caldo, coprirsi quando ha freddo, mettersi gli stivali quando è bagnato, in qualche modo comprendere gli impatti di un clima che cambia sulla vite è in qualche modo diventato utile, perché monitorando anno dopo anno le variazioni di crescita, parametri qualitativi, maturazioni, poi vi mostrerò qualche dato anche su questo, degli effetti del cambiamento climatico sulla vite, si comprende non solo la risposta della vite a queste forzanti ambientali, ma si comprende anche come sta cambiando il clima. Quindi questa è la doppia faccia della medaglia. Oggi vi parlerò un po' di basi fisiologiche, non pensate troppo complesse, però qualche studio che abbiamo condotto, qualche analisi che abbiamo fatto, che mette in luce anche quali osservazioni possono essere fatte in campo e anche quali strategie possono essere messe a punto per gestire le situazioni che ora usciamo da una stagione sicuramente molto critica, ma questo non vuol dire che la prossima non sa di meno, ma magari sarà estremamente opposta. E proprio da qui voglio partire. Eccola, slide, perché non mi si è... Ok, allora, non so se avete mai visto, negli ultimi anni si è vista molto spesso nei media, ai telegiornali, in qualche modo questo grafico che dopo ve lo faccio capire meglio con un'animazione, ma cosa mostra? Mostra l'andamento delle anomalie di temperatura anno dopo anno, dal fine del 1800 fino all'anno scorso. E in qualche modo si assiste a un cambiamento netto di quello che è stato e che è l'attuale trend, l'attuale scenario, a cui non solo noi, ma i nostri vigneti e non solo tutti in qualche modo le cose che stiamo producendo e coltivando sono e dovranno essere messe in atto per gestire queste forzanti, quindi un aumento continuo delle temperature. Ma vi mostro questa animazione che in qualche modo vi fa vedere quello che era una variabilità fino a quel punto di flesso. Quindi c'erano annate calde, annate fredde, annate medie, e poi in qualche modo le cose sono cambiate. Vediamo se funziona con i video. Eccoci qua. Quindi, come vedete, per ogni stato del mondo, andate a cercare il vostro, in qualche modo, anno dopo anno, si vede l'anomalia annuale sopra, sotto la media, colori caldi sono più caldo, colori freddi sono più freddo, e si vede che ci sono dei blu, ci sono dei gialli, degli arancioni, ed ecco che in qualche modo le linee iniziano un po' ad allungarsi e direi che iniziano a prendere un colore abbastanza lussureggiante. E questo è esattamente, se vedete in alto a destra, si è andata a disegnare quella che è la curva che abbiamo visto prima. Quindi questo cambio di rotta da quello che erano le temperature in epoca pre-industriale, in qualche modo, secolo scorso, e poi quelle a cui siamo ormai abituati e dobbiamo convivere. Ricordiamoci che tutto quello che stiamo osservando legate all'impatto del cambiamento climatico, che poi sviscererò, è stato ottenuto con neanche 1 grado centigrado a scala globale di aumento della temperatura media. È incredibile, si pensa a quanto potrebbe, e questa è la sfida che gli Stati membri hanno cercato di raccogliere per forzare la messa a punto di strategie di riduzione delle emissioni, di ottimizzazione delle efficienze, per evitare non solo che si arrivi a 2 gradi, ma già a 1,5 gradi. Ma questo è un altro discorso. Adesso riparte il video. Qual è il problema? È che non solo abbiamo assistito a... Vediamo se il mio mouse si vede, forse c'è il puntatore qui. No, sì, così, forse così si vede. Non solo abbiamo assistito ad un shift, uno sfasamento della media. Questo abbiamo detto circa 1 grado. E questo ha comportato, sì, un aumento delle giornate calde, una diminuzione delle giornate fredde. Ma il problema è che c'è stato anche uno schiacciamento della curva di frequenza delle giornate durante l'anno. E quindi si è ridotto il numero di giornate calde, aumentato il numero di giornate calde e di giornate fredde. Se i due processi, shift della media e spostamento della riduzione della varianza, fa sì che ci sia un aumento molto molto elevato di giornate calde, in qualche modo le giornate fredde quasi spariscono. Adesso ci lamentiamo in questi giorni che fa -1, -2, ma fino a settimana scorsa c'erano 17 gradi, almeno dalle mie parti, quindi direi che in qualche modo siamo un po' a credito, però fa sempre strano. E una definizione, un po' di semantica, qual è la grande differenza fra cambiamento climatico e riscaldamento globale? Il riscaldamento globale è quello che vi ho mostrato nel grafico, una curva continua, e quello a cui stiamo assistendo è un aumento continuo dell'aumento delle temperature. Ma in realtà questo non è cambiamento climatico, è uno degli effetti del cambiamento climatico. Il cambiamento climatico aumenta la variabilità. Ed ecco che abbiamo variabilità in termini di precipitazioni, di neve, vento, innalzamenti del livello del mare, eventi estremi, e questo fa sì che ogni giorno, ogni mese, ogni anno si registrino dei record, ma anche record opposti, magari molto vicini uno all'altro. Il mese più freddo degli ultimi 150 anni seguito dal mese più caldo degli ultimi 300, e questo lo stiamo vivendo anno dopo anno, e i record vanno sempre più ad aumentare, e questa è la grande conseguenza del cambiamento climatico. Quali sono le cause? Le cause, ci sono sicuramente delle cause naturali, e in qualche modo ci sono degli effetti legati ai vulcani, ci sono i cicli solari, ci sono in qualche modo effetti legati alla deforestazione, e qui si entra nelle dinamiche antropogeniche, quindi umane, quindi i cambiamenti di uso del suolo, le emissioni, però in qualche modo è stato ben accertato che il nostro contributo ha superato ben di molto quello che è la variabilità naturale, e quindi in qualche modo è stato accertato che l'uomo è stata la causa di questo cambiamento. Ma entriamo un po' con i piedi in vigneto, voi direte anche ora. Questi sono gli effetti di questa grande variabilità. Scusate, ogni tanto tossisco, ma sono un po' malatuccio. E quindi assistiamo a eventi di siccità, seguiti da eventi di eccesso idrico, sfasamenti fenologici, aumenti della temperatura, cambiamento dei pattern delle precipitazioni, quindi pattern stagionali, quindi molta pioggia in poco tempo, poche volte. Queste famose bombe d'acqua, che una volta erano i gavettoni, adesso sono diventati questi grandi eventi di precipitazione che fanno cadere quantitativi annuali in poche ore. E questo sicuramente rappresenta un grosso problema per la vita. Ne vediamo un po' qualche spot. Questo è uno studio che abbiamo fatto qualche anno fa, non è aggiornatissimo, però ci sono dei lavori che hanno ottenuto dei studi più aggiornati, ma già cosa si vede? Questo grafico si può osservare in ogni pallino verde, rappresenta il giorno dell'anno, che è rappresentato da questo asse a sinistra, in cui si è raggiunta la determinata fase fenologica, quindi il germogliamento, la fioritura, l'invaiatura e la raccolta. Nel periodo 84-2012 non c'era stata una grande variabilità per quanto riguarda l'epoca di germogliamento. Se andiamo a rifare i grafici con i 10 anni successivi, ho come l'idea che anche quella curva inizierebbe a pendere con un anticipo sostanziale. Ma se andiamo proprio a vedere l'effetto sulla raccolta, se guardiamo quella che è la pendenza di questa curva, che va in qualche modo a spiegare questa variabilità, che è la linea gialla, il coefficiente ha un coefficiente di circa meno 0,8. Facciamo finta che sia un meno 1. Cosa vuol dire quel meno 1? Vuol dire che noi ogni anno abbiamo perso negli ultimi 20 anni un giorno nella data di vendemmia. Vuol dire che ogni anno si vendemmia un giorno prima. Infatti, se fate un po' mente locale, adesso, per carità, c'è sempre una variabilità, ma alcune vendemmie iniziavano a metà settembre, finivano a metà ottobre. Adesso ai primi di agosto già si parte e poi si finisce a fine settembre, o in qualche modo si è molto più contratta la stagione. Questo crea grossi problemi. Perché crea problemi? Perché in realtà non è il fatto che sì, semplicemente l'uva è matura prima. Il problema è che l'uva va a maturare quando le condizioni ambientali non sono ottimali per andare a formare, a sintetizzare composti di importanza enologica su quelle uve. Quindi escursioni termiche, notte e giorno, ma abbiamo rischio di siccità, ondate di calore ancora in agosto. E quindi ecco, questo rappresenta sicuramente un grosso problema. Parlando poi di stress idrico, quindi quali sono le conseguenze e gli impatti per una pianta di condizioni di stress idrico? Intanto la pianta inizia a ridurre la sua fotosintesi e quindi inizia a calare la sua crescita. E dietro la sua crescita c'è tutto il metabolismo della pianta. Chi ha girato in campagna quest'estate avrà visto delle invaiature che sono durate settimane, Perché? Perché la pianta era inchiodata, termine scientifico, era ferma, non riusciva a muovere un dito, per cui tutto si è rallentato, si è fermato, con delle conseguenze importanti, perché alcune evoluzioni dentro all'uva sono continuate, quindi si sono creati degli sfasamenti fra quella che è una maturazione tecnologica, che si è raggiunta prestissimo, ma quando ad esempio la maturazione fenolica era ancora indietro. E questo ha creato dei grossi problemi e creerà purtroppo dei grossi problemi. Il problema lo abbiamo conosciuto in qualche stagione in cui si sono verificati non solo gli stress idrici, ma anche gli eccessi idrici. Quindi abbiamo situazioni in cui i vigneti sono rimasti allagati per mesi, 2014, primavera, in realtà inverno, quindi gennaio, febbraio, marzo, 40-50 giorni in cui i vigneti sono rimasti allagati. Ecco, questo ha generato dei grossi problemi a quegli apparati radicali di quelle piante, che non hanno potuto approfondirsi in quel momento, quando era in realtà un loro obiettivo andare a prepararsi per i momenti di forte stress che sarebbe arrivato invece durante l'estate. Quindi la pianta poi si trova in grande difficoltà. Vi mostro un'esperienza che abbiamo condotto qualche anno fa che aiuta proprio a comprendere quanto è dinamica la risposta di una pianta in condizioni di stress. Una prova fatta nel sud, quindi nella Puglia, un'azienda molto grande, famosa, che aveva a disposizione un bel numero anche di pozzi per avere acqua a disposizione, anche se andava a pescarla a 600 metri sotto la superficie, quindi immaginate i costi, però questo che vi mostro è una situazione i pallini verdi rappresentano la conduttanza stomatica, vuol dire quanto erano aperti gli stomi per compiere traspirazione e fotosintesi. Linea rossa è la radiazione solare, quindi estremamente giornate pulite, non c'era una nuvola a pagarla oro, maledetta. Linea blu è la temperatura, quindi si sono raggiunti 44-45 gradi. Questo è il giorno dopo di un intervento irriguo, quindi la pianta si sveglia, parte, lavora fino a mezzogiorno, poi inizia a chiudere perché va giù la radiazione, la temperatura inizia a scendere, chiude e va a dormire. Il giorno dopo la pianta si sveglia, parte gagliarda, tuttavia un po' prima si accorge che qualcosa inizia a non tornargli più. Sono passati 2 giorni dall'ultimo intervento irriguo e quindi inizia a chiudere già alle 10 di mattina e poi inizia quindi a respirare tutto quel carbonio che aveva fissato. 3 giorni dopo, chiude ancora prima. 4 giorni dopo la pianta si sveglia e va a letto subito. Per tutto il resto del tempo la pianta deve dissipare tutta quell'energia che riceve, radiazione, temperatura, senza far evaporare l'acqua, quindi senza termoregolarsi, con grandi problemi legati alla qualità, ma anche alla sopravvivenza proprio della stessa pianta. Come si può andare a monitorare questi andamenti, misurando quello che è il potenziale idrico fogliare? Ci sono aziende...
Franco, ti ricordo ai 5 minuti.
Sì, ho visto il messaggio, okay. Grazie.
Grazie.
Quindi ci sono delle strumentazioni fine per monitorare lo stato idrico dei tessuti della pianta. Ci sono delle termocamere che ormai anche a pochi euro, tra virgolette, permettono di avere un chiaro feedback di quella che è la capacità termoregolativa di una pianta, che è sicuramente funzione di quanta acqua ha per traspirare. Quindi già si vede rapidamente se una pianta è in stress, ma anche guardando l'apice del germoglio uno vede già un apice a pastorale con i ticci che vanno ben oltre l'apice ben aperto. Quando inizia a chiudersi e a raccorciarsi si vede che non c'è più accrescimento e questa fase qua è molto più precoce rispetto a vedere foglie che si disseccano o sintomi molto più macroscopici. E questo deve aiutarci già a capire le fasi iniziali di queste fasi di stress. Ora provo a spiegarvi questo grafico un po' complesso. Che cos'è? Il colore, i pallini rossi o blu rappresentano le più alte relazioni fra le anomalie di maturazione, che in questo caso rappresenta il contenuto zuccherino. Qui abbiamo i mesi degli anni in ogni quadrato e qui abbiamo il grado zuccherino. E qui abbiamo quindi quanto più l'anomalia meteorologica è correlata con l'anomalia di maturazione. I colori più rossi sono anomalie positive, quindi ad esempio qua abbiamo le precipitazioni per la Garganega, vediamo che delle anomalie di precipitazioni hanno un impatto in ritardare la maturazione, in particolare ad agosto, mentre per le massime temperature vediamo che delle anomalie di temperatura sempre fatalità ad agosto anticipano quella che è la maturazione. E quindi quello che assistiamo è degli sfasamenti, quindi abbiamo delle anomalie anche nell'interpretare quello che
abnormalities in the interpretation of the winery opening and programming, harvesting. So what about the long and short-term strategies that can be put into play by the wine grower? Of course, we have some structural changes, a change in graft combination, variety of rootstocks. There are some very interesting rootstocks, new varieties that are more resistant. And then let's change the growing system, going back to trellis methods that cannot be mechanized. And you can see the temperature during the day. Here we can see the temperature reached during the day in the pergola. There's still the air temperature. So you can see the pergola may have a downside, but for certain viewpoints, it is still used. Change the row orientation. This is a model study carried out by colleagues in South Africa with different row orientation and the impact on long-term adaptation strategies. Well, if I then look at short-term adaptation strategies, I can implement different strategies based on modifications of growing and ripening pattern. I can increase the wine yield, and I can have a production excess with delayed ripening. If that is my goal, by late shoot trimming, late irrigation before harvest. 20 years ago, you couldn't even think about it, or implementing late winter pruning, the goal being preventing late frost and delay the phenological phase.
This technique tries to calibrate and limit the damage to try and change the maturing and to harvest when it's best for the plant to be able to use its product. And therefore, we don't want something which is very early. We want a horizon which takes place late, generating stress, if you like. Using nets, for example, kaolin, which are going to help to increase and control the temperature of the vineyard, to use, as I say, canopy shading and the use of anti-transparents. Now, I think I've come within my allotted time. I'm sorry if I did cough, but I'd like to thank you. Thank you very much, Franco, for this synthesis, and all the best for your code to get better. Okay. Now, we, in fact, have met Martina on several occasions when it comes to what she's doing in research as an agronomist in the field. So I'd like to give you the floor to hear from your point of view. Okay, we're going to become practical. Okay, I'd like to thank you. I thank you personally, Adriano. It's great to be involved in this sort of initiative. Thank you for inviting me. And especially, it's fundamental to communicate the possibilities that are out there with regard to the solutions. Climate change is something we're all facing, and we are paying for the effects ever more dearly as years go on. As a consultant, I work throughout Italy. I also work in California, trying to find the solutions that we can put in place right from today to try and mitigate or help the plant to adapt to these changes that we are seeing. And over the years, I have become specialized in everything that has to do with the microbiome of the soil. If we're talking about the microbiota, of course, the most important thing to say is that mentioning what I said before, mitigation and adaptation. In other words, we have two objectives to try and give priority to the plant and to try and in 30, 40, 50 years to be able to have as few consequences as possible. So what can we do? The soil under our feet contains a whole series of microorganisms and bacteria that can fix carbon in the soil. I cited a documentary and a book which I really suggest you look at and read, because these talk about how the soil, in fact, could be one of the agents to mitigate climate change. We talk about photovoltaic panels, LED bulbs, and so on, but they are all solutions, these, that don't really give an immediate impact in terms of fixing carbon and to take out CO2 from the atmosphere. We're not just talking about CO2, of course, but also a couple of other gases which cause problems. For example, nitrogen peroxide. Everybody talks about CO2, but we forget that there are things like nitrogen peroxide, which is 270 times more dangerous than CO2. And this gets released into the atmosphere in the vineyard. This is not used, nitrogen is not used that much, but in other crops it certainly is. Now, temperatures are not just rising in the atmosphere, but also in the vineyard. And I'd like to give you here a few pictures that I took with my thermal camera in the vineyard. This is 2022 in August in Sangiovese vineyard in Tuscany, where you see that on the soil, it's even 50 degrees. In extreme cases, in Barbaresco, without going to Sicily, you also get to 70 degrees temperature on the ground. But on the grape itself, on the bunch, the thermal image is very interesting because you see what's happening in the field. When we go there and look, we see a couple of sunburned grape bunches, but the camera tells us the damage that's going on. The central image, 42.3 degrees was the shoot and 38 degrees was the grape itself. Of course, this is highly harmful, especially for production. The leaf temperature of over 35 degrees, in fact, stops photosynthesizing and just stops its activity. And that means you'll have less color, less aroma, and you'll have plants that are completely blocked, closed down. And obviously, the acids will become degraded. So for sparkling wines like Franciacorta area, they're feeling the brunt of this increase in temperature enormously. Now, why have we got to this point? What are the practices that we have carried out very often in many soils? In the past, we have thought of grass as a weed, and that we took it out of away from the between the rows. And I always say that soil without grass is desert, because we take away a living organism which can fix carbon, but also can release radical exudates, root exudates, which are all important. And this is 4 or 5 tons per hectare of the sort of exudate that gets released into the soil. But we haven't realized this about grass, and you see the results over the last few years. If you talk about and think about the domestication of the vine, we have selected vines to produce more, but these vines are less resilient than the vines that we have in nature. What we had in nature were able to communicate with the microbial environment and send on specific signals to particular bacteria with regard to fixing nitrogen. Nitrogen we breathe, and we have 78% of nitrogen in the atmosphere. So that means that if we can get the bacteria to work, and we give them the possibility of fixing the nitrogen in the soil, well, then we could definitely do without any synthetic fertilizer at all, because the microbial population can fix nitrogen to an enormous amount, 900 kilos, for example, per hectare. So the sort of philosophy that we are developing is that very often we have susceptible plants. We have a low diversity from a microbial point of view, but also very few species that we have planted between the rows. And we have a high use of fertilizer, especially agricultural chemicals, because also fungicides have an impact on the soil. We have seen, and lots of papers, in fact, show the effect that we are having on the plant with the use of agricultural chemicals and the effect on the soil. So this is one of the many reasons why these microorganisms are no longer working as they should. Now, what effect does the microbiome have on the plant? Mainly, as it is in close contact with the roots. This is a test we carried out in the vase. It produces they produce new roots, which are very much development in terms of secondary roots. And secondary roots are those that absorb nutrients. And this leads to what? It leads to a plant with more roots, which of course is a plant with more sap. And from a physiological point of view, what does this mean? It means that the plant at the end of the day will have more sap and will be able to transmit the nutrients through the plant and will be able to mitigate temperatures both at the leaf level and also with regard to the grape bunch. Of course, we won't have phylloxera, which is due to drying of the leaves. The leaves will continue to be luxuriant and protect the grapes. And the other effect is that having more sap means that you can have also a reduction of 1 to 2 degrees in the grape bunch, especially when it's in the herbaceous stage. What does that mean? It means that for the production of sparkling wines, for example, the higher acidulous content is a good thing. So this acid, which is degraded after 30 degrees, now, if the temperature is lower, can be more accumulated because the plant synthesizes more and there's less degradation. So this is also a key to quality of white and especially white sparkling wines. And what does that mean also, having less sunburned grape bunches? It means that these extreme temperatures, if we don't have them, we can maintain the aroma within the grape. Usually in the agricultural field, the vine and the growing of vine is considered as the canary, like the canary in the coal mine. The vineyard is the canary, as the canaries were in the coal mine, because they're very, very sensitive to climate change. And like the canary in coal mines, it's the canary that first feels and is sensitive to high temperature and the first to suffer from these changes and these important stresses. Because you don't just have hot water or heat stress, you also have frost, you have hailstorms that are frequent, and year after year after year, with the canopy, which is ever weaker, you have a plant at the end of the day that doesn't accumulate more substances and accumulates less and less, even from the point of view of the trunk. So what are the solutions to this? The solutions can be very different. How can we maintain this microbiome? How can we protect the roots of the plant? We have to work on the soil. We have to start to not nourish the plant, nourish the soil, because these 4 or 5 tons of microbic biomass, when it's developed, becomes nutrients for the plant itself. So we have to look to the soil, not the plant. And if you look to the soil, well, then the root of the plant will be stimulated with all the advantages I mentioned before. So when we go into the field and we dig with a shovel and bring up a clod, if I don't find an earthworm, well, that means that in that soil, there's very little life. So we have to preserve not only the bacteria, the fungi, and so on, but also the insects that live in the earth. And we have to work vertically without overturning too much. And we have to maintain the soil as covered as possible, where possible. Of course, one thing is to say things, another thing is to actually do it. And that's why we agronomists go out there and try and help people make the best choices. And we have to leave these various species develop between the rows, and so that we have root exudates which are formed and which nourish the microorganisms. Another food, if you like, which is very much sought by microorganisms is good, well-fermented compost. There are many types of compost solutions. There are activators as well of the microbial part of the compost. There are many, many solutions, and everything that encourages life in the soil will then encourage and bring about greater growth of the root. So I'd like to conclude by saying that there is no life or wine without the microbiome and without soil. So if we really want to continue in the next few years to produce quality wines and wines of excellence, well, we absolutely have to look to that hidden half which is hidden under our feet and give it a lot more attention. And with that, I have concluded. Thank you very much. Thank you for that contribution. Thank you very much for your contribution. So let's remain concentrated on the soil and on the focus that you have mentioned, and you have described the microbiota. Now I'd like to give the floor to Alberto.
Thank you very much, Adriano. Thank you very much for inviting me to this meeting. I'm excited to be here and share my knowledge in soil microbiome, especially in vineyards. Let me share my slides. Yeah, here we go. Okay, perfect. Well, I'm the Chief Scientific Officer of Biomakers, a company that aims to decoding soil microbial interactions and translate into specific agronomic indicators. Also, as member of the International Union of Soil Science, especially for biology, I'm trying to apply also this knowledge into the science. Well, we believe that healthy soils are living soils, and also the FAO say that biology play a very important role in the soil health. And also we can measure that today with different tools that are available. We are using DNA to detecting the microbes that are living in the soil, their functions, and how they can be interact with each other, with a specific focus develop indicators based on microbiology, indicators about biodiversity, indicators about nutrition, stress, and also disease risk. This is one of my papers in collaboration with the Copenhagen University that we explore the soil microbiome around the world in order to understand what are the differences in the microbial populations comparing one place to others, and how different factors, environment, the culture, how we are managed the field, are impacting specifically in these microbial soil populations. One of the learnings that we get is there is a specific microbial fingerprints that we can get per specific locations. And the factors that are producing a bigger impact in these microbial populations, the physicochemical factors, are first, soil pH is a critical factor. But when we are talking about climate change, you can see that temperature is other factor that is affecting a lot to the microbial populations. Easy to understand. Cooler specific temperatures allow to not grow a lot the microbes. High temperatures also are impacting them. Regular temperatures between 20, 15 degrees are the perfect environment to get more microbes growing. Well, with this specific knowledge, also other factors like moisture is important. Organic carbon that was mentioned before by Martina play a very relevant role in how the microbes can survive and what kind of microbes we can identify. But again, the key thing is taking the soil samples, analyzing what are the microbes living there, and getting specific indicators. Biodiversity, nutrition, but stress adaptation is one of the indicators that can be more linked with the climate change. At Biomakers, we understand stress adaptation indexes in group of microbes, plant growth promoters, that are able to provide a specific similar phytohormones to the plant that allow the plant to resist about the stress. And specific indicators in our panel are, for example, the ACC deaminase. This specific indicator means that if the level is high, there are a lot of microbes, plant growth promoters, that are able to provide to the plant this kind of compound that allow to the plant to resist, for example, the drought, better than other plants with other environments without these specific microbes. Other, for example, are exopolysaccharide production, or, for example, salicylic acid. Well, these are the main indicators that can be linked with the climate change, specifically for if the temperature is increased and more drought can happen in the vineyards. Okay, we explore this, our database. You have here a picture of the level of samples that we have in our database, depending on the country. We have many samples and clients from US, from Spain, and growing in other parts of the world with a good level of resolutions. And here's some of the trends that we are getting. The indicators about stress adaptation in general for natural level are very high at global level. And if we can focus, for example, in ACC deaminase or exopolysaccharide production globally, well, we can observe that more than 50–60% of the samples that we are analyzing in vineyards are in levels medium or high. But what happens if we run this for specific countries? Well, this is the graph of different countries, most of them from Europe, that we are getting the percentage of samples that we get high or very high level of, for example, ACC deaminase. And curiously, countries like Denmark are on top of these levels. Other countries like Argentina or Chile too. And in the case of France, Germany, Spain, or Italy, and in medium average of this kind of indicators. Or for example, Croatia here, without samples today with high or very high level of this specific indicator. How can this index be related with the potential impact of climate change per country? Well, I found this graph that allowed to see that what are the countries that we can observe bigger effect because climate change. And curiously, Denmark is one of the countries that now there are vineyards that with high impact of the climate change potentially. And in this case, we are getting high level of vineyards with very high level of plant growth promoters linked with ACC deaminase. That means that in that place, something is happening now. And the plants, the vines are recruiting with exudates, chemical exudates, are recruiting this kind of plant growth promoters that naturally can live in that place. Well, this is very important because these specific microbes are playing a role to allow the plant to resist this specific impact of the climate change. Well, what happens if we analyze not a global scale, if we analyze these kind of indicators of stress adaptation in a small, in a vineyard, in a winery, a specific low scale, no? Well, in the picture, you have different lines. Each line is a specific sample. Here we have, I don't know, 30, 40 different samples. Each color indicate the level of the index for the specific vineyard. Yellow is low level, blue is high level. In this case, we were analyzing different vineyards in 3 different years, from 2018 to 2020. Well, we were collecting the samples in June, and you can observe that something happened in the case of 2019, because the colors that we are observing in the chart are more dark, no? It's like blue and dark. It means that this level of indicator increase. And what is the difference during that time in these specific locations that are curiously from Napa Valley? What happened in that? Well, we can see that in the reference of the temperature from this period of time in June of 2019, there is a peak of a specific high temperatures that can impact. And plant is reacting to that, recruiting these specific plant growth promoters to allow to resist that peak of drought during that specific period. This is another example of application of the technology. Okay, but not all is about what happened at the level of the environment. No, in the environment is putting us the context, but the culture is impacting also in that context. We aim to explore not only the microbes that are present in the vineyards, in the whole management are impacting in the microbes that are living in vineyards globally, publishing this paper. We find, using network properties, that under conventional agriculture, as Martina mentioned before, we are specializing, decreasing biodiversity and specializing the diversity, specializing because we are putting some specific chemicals that are food for microbes that allow some microbes to survive and grow, and decrease the level of other microbes that can provide another functions. Well, we observe that globally, under conventional agriculture, there is a kind of a specialization of the networks and the kind of relationship that we can observe in the microbes, compared with organic or biodynamic agriculture. In that case, we can observe more density in the networks. That means more different microbes in the environment, but also non-specialization. There is not a kind of influencer in the network that is recruiting others around. Here is a more collaborative network. Well, this is an ecological approach. And what do you prefer? A system that you have many functions and many microbes, and if temperature change a lot or any other factor happen, the life can continue and survive? Or a very specialized system, very efficient for sure, because we are like manage that field in the way that we want, but with only less biodiversity, and that specialization, if something happen, change temperature, high level of rains in short periods, can affect a lot that ecological structure and destroy probably that specific community. Well, this is something that we can measure also, and here is a kind of example of how manage can allow to get more resilience in the vineyards, more resilience in soil biodiversity than maybe another factors. Well, my last slide is a slide focused on the next question. What kind of product or management can improve that plant growth promoters that can help the vines to survive? Well, this is an example of cover crop, also in US, in Virginia. Well, we compare cover crop with and without cover crop. And in the picture, you can observe that with cover crop, there is an improvement of ACC deaminase to resist the drought, to promote plant growth promoters, and also exopolysaccharide production. It's curious that we have not, we need to build this new data to understand what kind of solutions, products, and management are impacting less or more in these kind of indicators that are essential to the resilience of the vines and the vineyards. Thank you very much.
Grazie mille Alberto, e una volta in più grazie per la
Thank you very much, Alberto. Thank you for a great summary. I am now going to share my screen.
Ok, datemi cenno.
Okay.
Visualizzazione. Datemi cenno se...
Can you tell me if you can see, if everything's okay?
Vedete la presentazione?
Can you see? No, we can't see yet.
Ho condiviso. Scusate per l'inconveniente. Riprovo a fare l'operazione, scusate.
Sorry, says the speaker. Just hang on a minute.
Ok. Immagino che ora funzioni meglio.
I think it's working now, right? Can you see it?
Sì, vediamo tutto.
Yes, we can all see.
Grazie mille. Allora, è molto più facile parlare ora.
Well, it's easier to speak now because, in fact, the subject has been delved into very, very well. Now, I'd like to rapidly go through some slides to answer the question that I've been answering and asking myself as a consultant. What does the farmer that I'm speaking to need on the basis of his situation? Well, I'll go back to this great classification that we have given ourselves. In the soil of a farmer, the farmer has to find agricultural methods which get the soil to work. And I won't go into details about this because we've already seen what it means to get the soil to work. What does the vineyard need? It needs farming methods which, both through the management and also the type of plant, can not only manage climate change, but also anticipate it. And what I see increasingly is that we have to intervene within at the level of the organization of the farm, because the farm works and the farm works on the basis of people and what people do. So we have to go back to this whole idea of tradition in agriculture, and we have to understand that tradition is really a successful innovation, and we have to be very much more in tune with the climate elements that are coming to the fore more and more. So if we see what happens in the soil because of climate factors, what do we need in farming? And on the farm, we need something or a technique or a series of techniques which will help to increase the quality and quantity of organic matter, increase water absorption capacity, increase the capacity of storing water in heat stress, and reduce erosion and implement the soil structure. So what can we do to pinpoint what sort of farming practices we should introduce? This is a very important study of the RAM, who's French, and they put together more than 120 studies. It's a meta-analysis identifying the agriculture that helps the ecology of the soil, the basis of what we've seen. And it's important to be able to measure all the methods from the conventional, biological, and biodynamic methods. And the conclusions say that the biodynamic farming represents the highest soil ecological quality and maintains the soil. This is followed by organic, and then finally, last in the list, conventional farming. I won't, in fact, use value judgments, just scientific evidence to see what works best and what works less well, because the farmers that I work with have exactly the need to know what works best. Once again, the soil, if we look at a European level, we're in Switzerland, and this has been tried for 40 years of rotation of cereal crops, and we can apply this way of seeing the effects
su diversi metodi agricoli,
various farming methods and the effects that these farming methods have on the soil. So this photo here on the left, I mean, how can we class it? This is a method which is biodynamic, and it has biodynamic compost, it has rotation, and also it therefore has all the techniques which protect and increase the organic matter in the soil. On this side here, we have chemical weeding, we have chemical and systemic pesticides, which are used to fight against disease. Then there's a consumption of minerals, and biodiversity is not taken into account. So we can look at these pictures in terms of agricultural practice. Again, it's a scientific study to not give value judgments, but just to give observational data, which is very important. And if I put these considerations into the situation of a farm, and the photos that you see are farms and vineyards that I work with, and they're very much linked to the slow food world and the slow wine world, and gives you an idea of what happens. This is what happens in a large vineyard, 1,000 hectares, when we go from a traditional method to a biodynamic farming method, and we can see what happens to the soil. And we can look at these with scientific evidence, and the farmer too can measure and see what's happening to his soil. He can do it in the Veneto area, and here we have a Veneto farm. Situations of more aroma, darker soil, all practical indications that show the difference and that every day the farmer can see the benefits of. So how are we putting this into practice? Working in the various areas and internationally, we all know full well how rootstocks work, and we know what we can do. These are three examples from Trentino, Tuscany, and Sicily, where I am today. And the use of rootstocks is of great help with regards to resistance to water stress. And we use new rootstocks. So innovation is the way to go. And we have made many trials. So here too, we have to change, not just for the sake of changing, but because we're pretty sure, or we believe that these changes will bring benefits. Again, I go down to Sicily again, and then I go back up to the Trento area in Italy to prove what we saw before. In other words, changing and reintroduction of pergolas. Here you have an empty field. Now it has a pergola. Grapevine. And so this is what's happening, and not just in the farms and vineyards that I have shown you here. Again, producing living organic matter with green manuring, for example. Here we have a poor soil, thick soil. This is in Spain. We have to produce organic matter in the farm because that's an ecological and economically sustainable way of supporting the soil in our particular area. Green manuring just doesn't mean saying I'm going to cut it and then move it into the ground. It doesn't just mean that. We have replanting, regrowth, and so on. So that really is what green manuring is all about. And we know this. We know this gives great elasticity. In fact, what we do in 1 year is not necessarily the sort of thing we'd plant the next year. And then composting, here we have various examples in various vineyards of various sizes, and we can also use the stems and for compost. This produces really good organic material, and we need that organic material. If it's very good, we can use less of it, and therefore we can move less masses. We have technology, let's use it. However we look at things, in fact, we can do something of benefit. Here we have vigor maps of the plant, we have agriculture interpretation, winery maps of the soil, and we can see the particular type of terrain of the map, if there's a slope and so on. We have to use the map. Here we are in Tuscany, so we have a differentiation, not only of the soil, but also the vigor of the plant. If we use the slope properly, and if we use the plant in a particular way. I'll go quickly because I just wanted to give you a very quick overview of what we can do and how we're working. We have seen this is an example, a concrete example of what we're doing in a vineyard, i.e. it's good to change the orientation of the rows because scientific studies tell us that the orientation of the rows is something which is so important. And in fact, one just has to take the decision to change the direction of the rows. It's a drastic decision, if you like, but it can work. we have also seen here what we've seen before. Alberto Franco, Martina mentioned the temperature increase and the effect on the vine and on other crops as well. We're all understanding that there are actions that can be taken. They all have to be coordinated together. There's not just one solution, fix-all solution. We have to meld these solutions together. Now let's come to pruning. Pruning with e-warnings, for example, we're living in years where we are delaying the pruning, and we realize that the later we prune, the better we can protect against the frost, the late frosts that we mentioned before. And here, for example, we see that it's very often counterproductive to prune too early. And very often, however, we have many doubts. We have more uncertainties than certainties. Certainly, we're trying, and we're trying to see the limits of certain actions and factors, because we're living an observational study and we have certain disappointments, it's true, but sometimes we have great advantages when we change the direction, for example, of the rows. We're not fully sure that that's completely the right one. Let's now come to the human factor and how climate change factors can be impacted. I think that, of course, when it comes to climate change, what we need in the farm and in the vineyard is training and bringing in innovations. We have to loosen up mindsets and facilities. I am engaged in coaching, or actually on the field, and I think that's very important, because the objective of a vineyard is very often pushed back against, because things have always been done in that particular way. People are frightened of change. So we have to work at a person level to be able to change mindsets. And we have many weekly meetings with the team so that people can share their intuitions, because we also need to give voice to people who have insights, and also we have to use the collective intelligence that is there among the team. Very often I've had business-to-business fora with various wineries, and when we are faced with the lack of true scientific answers, when it's very empirical, very often if we have wineries coming together and talking about quality and an ethical way of working the land, much comes out of it, and exchanges are made of intuitions of new practices. That's very helpful. These are things which are extremely positive for everybody. In this particular case, we had a meeting among 3 wineries, and they were company teams, and they exchanged ways in a structural way to see how they're going about things and to look at it. And we started to then talk about discontinuity, the need for discontinuity, bringing animals in the vineyard, creating organic matter in a different way. All these things were discussed. The human factor, therefore, I think is really, really important, because if we don't take people by the hand and introduce innovation, and also face the emotions that innovation gives rise to, well, I think that we will be a bit late in our action. So we really have to have proactive factors at work to bring in solutions. So we have to, therefore, give our trust to that factor which brings together soil, vineyard, and humans. and that is that all three are living systems. And I think this will allow us to create relations between the soil and the vineyard and the human and the soil, and so on. And I think that this is the real truth that has been hidden for so many years and not given its right value. And I think we have to put these three environments together, not just in terms of looking at performance, but also seeing all these three as a living system that work together. And I'd like to end with a sentence of Giorgio Celli, who was a pioneer of agricultural farming. He says that a behavior is intelligent if it responds, if it solves new problems. That was his slogan. So we have to develop intelligence, and we have to be able to develop intelligence by developing new solutions. I'd like to leave you some literature. Some of the wineries that I mentioned are here. These are my contact details. So I'd like to thank you for your attention.
Allora. Mi sentite?
Can you hear me?
Perfetto. Allora,
Well, Maddalena, let me ask you, how much time do we have left for the Q&A? We've received quite a few questions. We still have some 10 minutes. Well, I can see our friends from Ausonia asking, a north-facing vineyard can mitigate the impact of climate change from the region of Abruzzo. We've just looked at this issue from different points of view, and I think I can tell you that more specifically, I cannot get into your personal situation, but we've looked at the impact of orientation. It does have an impact, which is either negative or positive, depending on the type of vines, red wine, white wine, bubbles. May I make a comment? It might probably the question is about exposure rather than raw orientation. Well, I think he's rather talking about the exposure. So the north-facing vineyard can have a reduced impact and be better able to adapt to climate change. Was this the topic of the question? Of course, there are lots of variables to be taken into account in the region of Abruzzo, for instance. Is it a trellis vineyard? And then the problem would be solved. It just depends on the type of planting system that has to be taken into account. We shouldn't look at one factor only, because of the grapes have to ripen in the right time and in the right way. So there are so many factors that must be taken into account, and exposure is certainly important, plays a decisive role. Apologies for interrupting you. No, thank you. Thank you very much for adding something important to the answer. Sarah Lagarde, the question, what do you think on the competition between water of the vegetable coverage in the region of Veneto, especially when there's a limiting factor like water in the winter? Who's going to take the question? Adriano, you've certainly studied this issue a lot. You live in Tuscany and you know more about it than we do. And I attended a conference a few days ago about the different or water content between grass and planted areas. Grassland retained more water as exposed to lower temperatures. So the soil is always covered and never exposed to very high temperatures up to 70 degrees centigrade. So there's more transpiration in soil exposed to 70 degrees or a grass-covered soil, because, you know, the grass cover plays no role except protecting the soil against high temperature. So I would like to show you a photo. It's actually 2 cylinders of soil. I performed an infiltration test where you can see biodynamic soil. So a lot of organic substance next to a soil that's always been worked and tilled. There's less infiltration capacity and less water retention potential. So we need to modulate the different situation, the grass cover and the tillage, and create a right balance. It does change a lot from one vineyard to the other. Yes, of course. I'd like to make a comment on your last point. Yes, an extremely interesting issue, extensively studied. I think we should be very pragmatic about it, even in the same vineyard, in the same winery, where we have different exposures, vines, rootstocks, they're very different, and the vegetable or the plant cover may change. So we need to focus on biodiversity as a method. So doing different things on different soils, even during the same year. It's a complicated thing, but we know our job is quite complicated. Climate change is bringing about an increased complexity in our work, and we need to embrace it to make our farming systems more resilient. So we can't focus on specialization. That's extremely risky. We need to go for biodiversity in order to avoid taking the wrong decisions. There's an article, I think it was published last year by Professor Poni's group of the Università Cattolica del Sacro Cuore that tested the competitive effect in terms of transpiration in the grass and non-grass soil, and grass consumes 2 to 3-fold more water. And this is not necessarily a bad thing, but I need to know about it. So I need to assess whether it can be used in a useful way or set it aside if not interested. I think we should take a look about it. I discussed it with Professor Poni. It's an extremely interesting study, providing a useful insight into the problem. Thank you. Thank you very much for this comment. I have an additional question, probably the last one. We're running very late, so we need to close by 7:30. Alessandro Ciccarelli, the question: what are the bioclimatic indices? Can they help us mitigate or adapt to the climate change? Franco, do you want to take that question too? The bioclimatic index is very interesting. It depends on temperature and many other factors that are typically observed in one area. So you may want to choose one variety in order to reach a certain enological goals. Well, I don't know whether it's an adaptation or mitigation method, but you need to know that. And climate change is having an impact not only on the new wine growing areas in the north that are taking advantage of this trend in the UK and in Denmark, as Alberto mentioned. So some are favorably impacted, but then the traditional winemaking areas are negatively affected. After years and years of tests and trial and errors, we found a balance between soil and climate, what the French call the terroir. So the risk there is moving into the right direction and use our past experience effectively. So we need to know our soil features, our area, in order to implement the right treatment interventions like correct canopy management and step back and change previously made decisions because surrounding conditions have changed. Well, thank you. Thank you all very much again, Martina, Franco, Alberto. I would like to thank Slow Food very much. I'd like to close on 3 words that have come across loud and clear: knowing, observing, innovating. 3 words that we can all share, and I think these words can really help us developing the right intervention, responding in the right way to the climate change and its impact on vine growing. So thank you so much. I do hope you have some interesting take-home message from this call. I'd like to thank Slow Food and the organizers. I'll give you back the floor, Federico, for an official closure. I'd like to thank you all very much for giving us an overview, such a